how maybe poly can hurt our buildings more often than so not.
And they talk about poly at length and whether or not, like it's kind of up in the air now about whether it should be used at all.
Building sickness.
Or sick building syndrome. People start to see detrimental health effects when they're in a certain building for a long period of time. If it gets moisture in there, it has to get out somehow. And that's where I find the Proclima system is really strong, because all of the exterior membranes are highly vapor open and monolithic. Summertime, job sites are messy, they're dusty, and the dust usually collect on the membrane. And what happens there is that dust can actually clog the pores. It will limit the drying potential. So we have to be as concerned with how things are installed as Proclima in Germany is concerned with the quality control of their product.
And welcome to the Beyond the Walls podcast, the show designed to inspire construction of high-performance and sustainable buildings. I'm your co-host, Fellipe.
And I'm your co-host, JS.
Today, we welcome Aaron, product consultant for Eastern Canada at 475 High Performance Building Supply. Aaron, thanks for being with us today.
Yeah, glad to be here. And I know what the translation is for the podcast now.
It is the first time we're doing an English version, so it's a little trial. Let's see how this goes. We're very excited. We are a bilingual province, so we're staying true to our roots.
All right.
Right.
So, Aaron, tell us a bit about yourself, how you got started, and how you got started in your transition really to this position.
Yeah, sure. No problem. Well, I guess I started off as an engineering student way back in the day now, I guess. I can't believe how many years it's been. Started off in biomedical engineering at University of Guelph. Thought I was always going to be in the medical field. But yeah, one thing led to another, I suppose. Did a master's degree because I still didn't really know what I wanted to do. And then after the master's degree, I tried a little bit in the medical field, decided at the end of the day, it wasn't really for me. So I went back to working on site for a little bit, like I'd done for a lot of previous summer jobs. And then that's when I started to understand kind of why I was doing stuff when I was 14, 15 years old on a site, putting up poly. Didn't really know why I was doing it, but I was doing it. But through my engineering background, I kind of learned, oh, so now I know why I'm putting poly up. And then as I was building and being on site, I started to use, kind of the stuff that I learned in engineering, and I tried to become really interested in it. I became really interested in the idea of building science and stuff like that. And that's when I started to, not just work during the day on site, but scour YouTube for anything on building science, Joe Stiebrook lectures, Matt Reisinger stuff. And that's really when I started to fall into the rabbit hole of high performance, and when I started to become passionate about it, because it kind of combined my education with what I was kind of always doing, I guess, which was building. So, I learned about mass timber, I learned about Passivhaus and LEED, and I'm really sustainability focused as well. So I learned about, the impact that good architecture and good homes can have on the world. And that's when I found out about 475, and I've been in this job for, I think, 3.5 or 4 years now, something like that. So I've been servicing all of Eastern Canada, so Ontario, Quebec, and the Maritime provinces, or Atlantic Canada, if you include Newfoundland too. And yeah, it's been great. It's been great to have this position, just because I just got launched right into the high performance world with it. And I've been a part of projects and, met so many great people and great builders and architects, and they're all trying to do the same thing, which is what I love. And it's just great to be a part of all of these different projects and see how everybody does it a little bit differently as well too.
I'm sure your biomedical side too might have helped, right? I mean, a high performance home is a healthier home too, right? We're building a house that technically will lead to a healthier you, right? So I'm sure that had an influence as
It's a
well.
little bit, yeah, it's a little bit related too. Yeah, like I've also always been interested in health, and when I was driving to sites, I'd listen to the building science podcast, and I'd learn about how your indoor environment. We spend 90% of our time indoors now, and that has an impact on your health. And I learned about sick building syndrome and all those things. So, yeah, I would say that was definitely another thing that interested me in it. That energy efficiency standpoint, the comfort standpoint, and then the health standpoint as well.
I can definitely relate to the rabbit hole you're saying. I think I fell the same rabbit hole as you.
Yeah.
And ever since, like, I mean, when you go into that rabbit hole, you don't come back. Like,
No.
you can't unsee the things that you see. You can't unhear the things that you hear. So I think what's good is that there's a lot of available information, and I think in general for the passive house community, um, it's very everybody's very open, right? There's
Yeah.
enough work for everyone, and everybody wants to share. Think it's just for the common good. People like to share in the passive house community, and I've always felt like it was the case. And I'm saying share, it's also freely, right? So
Yeah.
YouTube's free. It'll always be free. There's a lot of resources. But definitely one thing is I think for our Quebec listeners and our French listeners, it's a bit harder because there's definitely less material out there, courses out there that are available in French. Hence why I think we also started this podcast. Hence why I'm very involved with Bâtiment Passif Québec, and we try to bring all of these resources to the French language so that our province can actually, and well, most of the people in our province can also have access to all that free information, right?
Yeah, for sure, for sure. Like that's definitely a catalyst for getting this high performance building industry going is having those resources. And I find that so many people are approachable and they're collaborative. And I mean, generally, I feel there's a lot of momentum in Quebec right now. I'm noticing that on Instagram and on LinkedIn. There seems to be quite a bit going on. Like you're definitely catching on for sure.
Well, I could definitely. So I was at a conference in Ottawa the other day, which was kind of
Hmm.
bringing together a lot of builders from all over
Yeah.
Canada. And one thing that I noticed is definitely per province, the goal is different. Um, well, not necessarily per se, but the goal changes. But in Quebec, it changes a lot more in terms of we have clean energy, clean and cheap energy. Um, and I think that we've always mentioned that Quebec was like a bit behind schedule but I think that now I kind of changing this narrative and the fact that our embodied carbon is really low. Sorry, our operational carbon is very low for our buildings. So the industry in general has not very been pushy of it. I think this new Quebec rebirth that's happening comes a lot also from low embodied carbon materials that we're starting to see, wood construction. So I think that's starting to now looking at maybe the 2030 horizon in Canada of trying to be um, well, having our embodied carbon targets, I think Quebec is going to start bringing it now back to the game and being sort of a leader when it comes to embodied carbon in buildings. So I think that's a different part in terms of Quebec. Even if we're consuming a lot of energy here, it's a bit cleaner. I'm not saying that we shouldn't do it. You should do energy efficiency for other reasons too, not just by the carbon that you're saving. But
Mhm. Well, I mean, one of the best carbon negative products that we have and is manufactured here comes out of Quebec, the nature fibers, right? The hemp bat insulation. And honestly, one of the questions I get asked most commonly is, with regards to the wood fiber insulation. And when is somebody going to start making this in Canada, which I hope happens very soon. It would help to really diversify the wood industry that we have and things like that. And then, yeah, 100% totally agree on the embodied carbon piece. And then also, just the other aspects of high performance building as well. Like, it's not just about the energy efficiency, it's about the health and the comfort. And also, when it comes down to it, as a builder, right? Like, you want to have confidence in the details that you're using and the materials that you're using so that you don't keep getting those callbacks as well, because that can really burn a lot of time and a lot of money as well as a contractor. If, say, you have a certain warranty period on a house and you keep having to go back to it to keep fixing things and fixing things.
Yeah, definitely. I think that the question of durability is also at stake, right? Um, Now that we're transitioning to a bit more these natural materials, I think we just need to always remember that building science is always number one, right? You have to use these new products or as a system, right? If you're building a building that's, yeah, sure, has low embodied carbon, but you're not using it adequately and your building's not going to last as long, then you're really just doing it for no reason. I think that's something that 475 has a great knowledge in terms of how to use their products as a system. You do have like a wide range of products in the building suite, like you offer insulation, you offer membranes, you offer windows, skylights. So you're kind of offer the whole envelope deal, and you really show how to integrate that as a system, which
Hmm.
is really important.
Hmm. Yeah, well, there's a couple key aspects to that system, right? Like, there's that idea of the high performance building enclosure, which is essentially four pieces to a big puzzle. It's the water control, the air control, vapor control, and the thermal control. And all four of those pieces working together to ensure that you do get that high performance building enclosure that stands the test of time, essentially. And then, kind of expanding on that idea is this Proclima system, this good air control layer, this good vapor control layer, but it's all predicated on good air tightness, good control layers, but then also resiliency measures too. So building airtight houses or buildings that have a capacity to deal with moisture, because when I was starting out and when I was first learning about the initial concepts of building science, one of the things that I would always hear so often was the house needs to breathe. It always needs to be able to, if it gets moisture in there, it has to get out somehow. And that's where I find the Proclima system is really strong, because all of the exterior membranes are highly vapor open and monolithic. And then even the one on the inside has the ability to be vapor open if it needs to. So you can get that drying potential throughout the entire year, as opposed to just a part of the year when you have something like a traditional vapor barrier, even. So it pairs up nicely with a lot of the low embodied carbon materials as well, such as cellulose or wood fiber or hemp fiber, because those insulations work well with the idea of good air tightness and also the ability to dry out as well.
Yeah, I mean, I think these were you touched on three key points, which kind of three main technologies that kind of differentiate your products. You said monolithic membranes. You said smart vapor barriers and solid acrylic adhesion. All three things that really differentiate your product. Can you kind of give us like a little short summary of what these really mean in terms of
Yeah,
products?
I'll try. Although, yeah, it might take a PhD to fully discuss what's going on chemically with those. I only got the master's, so
Give us
I
the
I
for
didn't get
dummies
that far.
version.
Yeah, yeah, yeah. So, I'll start with the monolithic one, I guess. So the monolithic WRBs. The word monolithic, no holes, essentially. So that means that The functional layer in each of our WRBs, this could be, the Menta 1000, it could be the Fronta Quattro or the Hero 3000. It's got what's called a TEEE layer in it. That's the acronym. It's like tetraethyl something something something, like a very complex chemical that's used on in the middle, and that is what's the monolithic layer, and that's what's doing all of the air sealing and the waterproofing. And essentially it works by it's just a really long chain of molecules that have kind of like a functional group on one side and the other that interacts with water such that it will pull the water molecules through the membrane actively. So this is a little bit different. It works differently than a normal vapor open air barrier because most of the membranes that you would use on the outside, like a Tyvek or a Typar or a traditional house wrap that you would see, they're microporous. So they act in kind of a simpler way, in a way, but in a way that isn't quite as advantageous as a monolithic membrane. So these microporous membranes, pretty easy to understand. They're just a sheet with a bunch of little tiny holes peppered through them. And these holes kind of act like Gore-Tex in the sense that they're small enough such that little vapor molecules can pass through them, but they're not so big that water droplets will go through them. So that's how they're vapor open. But when you're kind of comparing and contrasting monolithic versus microporous, the big difference and the big issue with the microporous membranes is that they have these holes. So an argument can be said about how airtight they are if they're microporous, because if they got all these little holes in them, all these little holes could add up and result in, a lesser airtight score. Or for instance, you could get Tyvek or Typar that's on a job site for 6 months or 8 months or something like that. And picture the summertime, job sites are messy, they're dusty, and the dust will usually collect on the membrane a little bit. And what happens there is that dust can actually clog the pores of the membrane, and it will limit the drying potential of those membranes. So if you get a perm rating of 40 on a Tyvek, it might be a little bit less if enough dust can get on there. And
And we
then
see that all the time, by the way.
yeah, oh yeah. Tyvek flapping in the wind all over the place. Yeah. Who knows how long it's been on there for? Yeah, there is a project that I would always drive past when I was living in Collingwood, and they had the house wrap on for 3.5 years, and then eventually they cladded it up. I don't think they put another layer on it, but yeah, it happens, right? So it's just an additional, I guess, resiliency measure when you're comparing the microporous membranes to the monolithic ones.
And what's the main problem of keeping the WRB on the outside without the veneer on it? What's the problem with that?
The main problem, I would say, isn't necessarily the dust. It would be exposure to the elements. So that would be water and sunlight as well. So UV radiation will damage a membrane for sure. It'll compromise a microporous membrane. Eventually, it will compromise a monolithic membrane as well. One of the things that we've got with all of our membranes is that they're multi-layered as well. So if you were to peel apart our membrane like a sandwich, you'd have the meat in the middle, which is the monolithic layer. That's the one that's the airtight layer and the watertight layer. And then the two on either end are the protective layers that are protecting that middle. So they're kind of like the pieces of bread. And the pieces of bread are there to protect and also to provide additional tensile strength as well. So yeah, if you were to take a look at any of these membranes, they're quite tough. They're kind of like a fabric almost, which is what you want. And that analogy is used all the time in building, right? Have that fluffy sweater around the house, or wrap the house up um, in some kind of fabric.
You mentioned earlier building sickness. What
Mhm.
symptoms can people experience?
Yeah, so I generally building or sick building syndrome is it's what happens when people start to see detrimental health effects when they're in a certain building for a long period of time or for an extended period of time. So this can result in a whole bunch of things. It can result in just being sick much more often. It can result in respiratory issues. There's actually a great book that I have right here, which is it's really kind of like the Bible when it comes to healthy buildings.
By who wrote it?
Joseph Allen and John Macomber. This is a great book. So this really outlines kind of what's it called, modern industrial hygiene and sick building syndrome very, very well. And what pretty much what they say in the book is that it oftentimes it's due to mold growth and things like that. People are sensitive to mold more, some people more than others, and these mold spores that get released into the air can cause issues. It could be differences in humidity as well. Like, for instance, I live in a 100-year-old home with single pane windows and has 15 air changes per hour. It's really, really dry in here in the winter, and that can cause issues too, for sure, with the respiratory system. So, yeah, I mean, if we're spending 90% of our time indoors, it's worth the investment to make sure that the air that you're breathing isn't causing detrimental health effects.
I think you. I mean, everybody has a different definition of a high performance construction. We even say it in the introduction of our podcast. Um, and I think your suite of products is really interesting. That it applies to. I mean, it could apply to any building, but a high performance building is not necessarily just in terms of its energy performance, which a lot of people might think. You had mentioned that high performance is much more than that. It's the health of the building. I think even that book that you just showed me has the word high performance and about of a healthy building, right? It also needs to be a building that looks nice, right? So I think these products are not just, when you say you sell high performance building products, well, it's not just catered to the passive house buildings, to the net zero buildings. They're really catered to any buildings. High performance buildings is not necessarily just one that is very, very energy efficient.
Yeah, for sure. For sure. 100%. Yeah, like I'm noticing that um there's a lot of different reasons why people would use our products or high performance products on a project. And it could be the clients who are really interested in energy efficiency. It could be the clients who are interested in ensuring, the health of themselves when they're inside. They want healthy indoor air. It could be that, many years down the road, they lived in an old house and it was always drafty and they want to feel comfortable in their own place. But one thing that I'm really starting to notice is shifting is that builders are going to these products just because they they like they trust in them. They believe in them, and they feel that it's something that they can rely on in a lot of ways. And generally, like a builder, a general contractor, like they put a lot of pride in their work. Um, and it's really great to see that, this idea of proper detailing and proper use of membranes and tapes is starting to get into the mainstream a little bit, because it's part of the building and theoretically part of the permanent enclosure as well. So why not, have it done right?
I think a great example for that is the smart vapor barriers versus the poly. I mean, as a builder, nowadays, knowing smart vapor barriers exist, I wouldn't understand why somebody would build without it. Maybe you can explain just a little bit the concept of a smart vapor barrier and the difference between poly and how maybe poly can hurt our buildings more often than so not.
Yeah, sure, sure. So there's actually a really great lecture by Trevor Trainer through Building Knowledge. If you ever have the time to go through that one, it's really fantastic. But yeah, it's again an English resource, but highly recommend to go through it. Building Knowledge has a lot of great resources on this. They call it the Critical Canadian Building Science series. And they talk about poly at length and whether or not, like it's kind of up in the air now about whether it should be used at all in a lot of ways because we're finding that in some applications, like for instance, basements, our previous preconceptions of what we needed to do in a basement is completely different because we're finding now through research that most of the drying in a basement wall in our climate is from the outside in. So when you have something like poly on the very inside of your basement wall, and most of the drying potential is from that outside in, that's where you can get quite a big issue with condensation or moisture building up on the other side of that poly. And while it's not necessarily as drastic above grade, it definitely still can happen where you've got warm, humid air going through your building from the outside and potentially condensing on your vapor barrier on the inside if you don't have enough continuous exterior insulation and you're, say, air conditioning your home. So
Or
that's where.
just when you're during construction, you're building
Mhm.
and you're starting already with wet surfaces
Yep.
and you're putting your poly up, right?
Yep.
That's also a great time to use it.
Yeah, for sure. For sure. Yeah, because framing, studs, plywood, it will always get rained on and it will always need to dry out one way or another, for sure. And that's where Intello comes in because it can open up and allow that drying to go all the way through the wall so that you get drying throughout the whole year as opposed to just part of the year, which is what you would get with a poly.
Which they seem so like to the naked eye, like these products may seem like the same thing just with a different branding printed on them, but you really have to look at it through the microscope. I think I encourage everybody to go look at it at the on Proclima's website or for Go Passive website or 475's website to just look at like molecularly how it's composed. That's science at its best, right? That's the future of construction. It's those products that are able to mimic, I guess, more of what nature actually does.
Hmm. Hmm. Yeah, well, I think that Intello was actually inspired by wood. Like it was inspired by almost kind of like plywood, like to have that smart vapor barrier characteristic in a membrane. So yeah, that's a cool testament to that. I mean, I've worked for 475 for 4 years, and I still don't quite know how Intello works. Um, but yeah, I'm sure that the scientists in Germany know how it works. I was able to go there in July and just look at how they develop all the products and meet some of the researchers, and it's amazing what they do to put their materials to the test, and they're still doing tests on materials like 20 years after they've developed them at the headquarters there. There's a part of the roof where they've got like 5 or 6 membranes laid out just exposed to the elements for years and years and years to see how the UV affects them. There's places all over the headquarters where they've got like pieces of tape stuck to walls and stuff because they're testing how it sticks to like a certain part of the wall and things like that. Yeah, it's really like a mad building scientist lab over there, which is pretty cool to see.
Was Proclima the first to come up with the smart membrane concept?
Yep. Yep, they're the first. Yeah. So the reason why I was over there in Germany was because we were celebrating the 30th year that the Intello membrane has been in existence. So it actually started off, the whole smart membrane concept started off as a paper based smart membrane. It was called DB, or maybe DB plus, and we still have that one available. It's meant, or it's really its only uses right now are for straw bale builders or rammed earth builders. Most of the people will use Intello Plus, but in case anybody still wants it, we've still got the paper based one. But yeah, I mean, these membranes and a lot of these concepts have been used in Europe as kind of the norm for a long time. So, I mean, while it seems like, maybe we're a bit behind relative to other provinces or other states or something like that, um, it's safe to say like we're all behind Europe with their building practices.
How can Proclima claim that their tape will last 100 years?
So this is actually pretty interesting. Obviously, the tape hasn't been around for 100 years, but what they did was they partnered with a couple of universities in Germany, and they did a rapid accelerated aging test to determine that it could last for about 100 years. So, I mean, while it's rapid acceleration test, it still took like 3 years to do or something like that. Like it was constantly, the tape I think was put in some kind of chamber with fluctuating temperatures and UV and things like that to kind of simulate 100-year time period. But it was still locked in that chamber for like 2.5 or 3 years. So it took quite a bit of a time investment to actually get that 100-year stamp. But at the end of it, yeah, it sounds like they're pretty confident with it.
For you, I've used. I have to say, the their tape, the Tescon Vana, which is, I guess, one of the most versatile tapes that you guys carry, is blue. I've fixed so many jeans with this, like jeans that you can rip. This thing doesn't move. I think you even gave an example. You showed me an example. You fixed your wakeboard with it. Like
Yep. Yep.
when the tapes get stuck, they don't move.
All
It's
the all the
amazing.
other product consultants have used it for a whole bunch of things too. Yeah, like our product consultant in upstate New York, he used it to reupholster his tractor seat. So he's got a Vanna tractor seat when he's got enough holes in the leather. I've seen people, yeah, like use it for pants and use it to for a tool belt and stuff like that. Some people have used it to hold the bumper of their car. I've seen a picture of that. We call them Vanna hacks at 475.
I'm guilty of that. I'm guilty of the car thing. My
Yeah.
light was like sort of like scraping on the floor. I stopped mid highway. I looked at what I had in the car. I only had some Vanna. I was like, well, it's the best tape I could have had.
Yeah. Yeah.
Yeah, Mythbusters should have done a special episode on Tuscan Vanna instead of the doc tape. They've done three
Yeah.
special
Yeah.
episodes.
So
Yeah.
That
true.
would have been funny. Make a boat out of Tuscan Vanna. Mm. We often talk about Western Canada with the step code, but you also have experience in the Maritimes. How is high performance building developing over there?
The Maritimes is really booming for sure. I think it's got to do with a lot of reasons. I think a lot of young people are moving out there, generally speaking. And when they move out there, generally younger people are probably interested in high performance and what can it can offer. So that's probably one piece of the puzzle. Another piece is there's a lot of great architects out there who are really doing great things, nationwide with regards to high performance. So I'm thinking of like Lori Rand from Habit and Natalie Leonard from Passive Design Solutions and Soltaire team. Like they're fantastic designers and architects that have an emphasis nationwide. And they're based in the Maritimes and they're primarily building in the Maritimes using the high performance principles and Passivhaus principles. So that's probably another piece of it. And then a third, I would say, would be that their grid is pretty dirty. Uh,
Filthy.
yeah. out in Nova Scotia and the Maritimes. So there's a big time incentive to make their houses more energy efficient. So for instance, there's a big heat pump rebate on, which I think is still ongoing, but it's meant to convert houses from oil to a heat pump, which I mean that stuff adds up. Like heating your house with oil, I think cost like 600 or 700 bucks a month. So there's a much larger incentive to go high performance with the energy efficiency piece than say Quebec or Ontario, where our grid is clean. Our grids are a lot cleaner, and we're not paying 600 or 700 bucks a month to just heat our place. So that would be probably the third big reason, I would say.
Yeah, 600 bucks for the whole utility bill. That's something I've seen on a
Yeah.
passive house here built in Mont-Tremblant.
Uh-huh.
So for the whole year, for the whole usage of electricity, not only
Yeah.
for heating, the
Yeah.
whole thing. So $600 a month. That's
Yeah.
a lot.
Oh yeah, for sure. For sure. They build a little bit differently over there as well. Yeah. So um one of the big trends that we're noticing in high performance building is that more and more builders or designers are opting for a self-adhered membrane as opposed to mechanically fastened. And in the Maritimes, or for the Maritimes' sake, one of the reasons is a lot of those houses are on the ocean, and the Maritimes gets crazy weather, snow, sideways rain, 100-kilometer-hour winds coming off of the ocean. And I will usually recommend or highly recommend a self-adhered membrane for those types of places just because once it's on the plywood or the OSB, it's not going to get blown off by the wind and end up, three doors down or something like that. So that would be one thing. Yeah, I find that in this job, everybody does things a little bit differently, which is pretty cool. So I try to, you know, learn from the builders as much as I can, learn from the architects because yeah, I'm still definitely learning things every day, and hopefully remembering it. And then if somebody has questions, I can hopefully apply some of that knowledge.
Here in Quebec, if I'm looking regionally and specifically into what I do, retrofits of older buildings that have Quebec frame construction or rubble foundations, solid masonry. Well, the liquid membrane for me is really my coup de cœur for all of the Proclima products, the
Mhm,
Visconn.
mhm.
Maybe you could tell us a bit more about how Viscon works.
Sure, sure. Yeah, so that's an interesting construction methodology, the Quebec block. That's how I know it. Like that's the English
It's
translation
mass
for it.
timber. It's the OG mass
The
timber.
OG mass timber. Yeah. What's the French word for carré à bois? It's called.
Carré de bois or pièce sur pièce.
Oh yeah, I've seen that before on drawings too. I've seen that before on drawings. Yeah.
Yeah,
I wonder, like, you can't build that way anymore. That's for sure. Just have like trees stacked on top of trees.
it's
Yeah.
crazy. Really,
But yeah, you see it a lot. You see it a lot in Montreal for sure. Some of those townhouses and some of the more, especially the older areas of Quebec, like that's just how they built. The OG mass timber, right? And that's where Viscon comes in quite a bit as well because you don't want to do anything to the outside. You can't wrap your beautiful brick facade in a nice fluffy sweater because you don't want to do that. You want to show the brick on the outside. So you got to do all your work from the inside instead. So Viscon comes in handy because it acts as that fluid applied air barrier for the project because you can't do a true exterior one on the outside. And that piss or piss, it's got seams in it that could be filled with horsehair or whatever, right? And Viscon is just a really super simple way of sealing everything up like a paint. So one of the really nice things about the Viscon is how versatile it is. So you can roll it on, you can brush it on, you could spray it on if it's a really big project. It's really useful just to hire a sprayer for a couple of days and you can easily, go through 50, 60 buckets of this stuff in a day. Um, and it's just a good fluid applied air barrier that you can rely on as well. So it's really stretchy as well. I don't have a sample of it, but whenever I do a presentation or I show people Visconn, like you can stretch it to be like 6 times longer than its resting length. So that's good for an air barrier to make sure that it's resilient for when things move. And then it's also vapor open and vapor intelligent to a degree as well. So it's really helpful for that type of construction you would see in Montreal, the OG mass timber, because that mass timber still wants to dry out a little bit, which is definitely one of the use cases for it as opposed to spray foam or urethane. Because as soon as you spray a whole bunch of foam up onto that, like there's no way to replace that. You can't do you can't do that anymore. Like it's you can't take it off. Same thing with a brick wall as well. Spraying a bunch of spray foam on a brick wall. Once you do that, it's really, really hard to get off. Um, but if you were to do, say, Visconn, some bad insulation and Intello, then you have a little bit more flexibility and it's easier to deconstruct. But then it's also much more vapor open as well. So brick also likes to quote unquote breathe as well. So it likes to have a certain amount of moisture within it and doesn't like to have a crazy amount of moisture, especially, which can happen in the case of a bunch of foam put up on the interior of a brick wall. And then you can get freeze thaw damage and stuff like that. So, yeah, having that Visconn and some vapor open insulation and then Intello on the inside, that's a pretty resilient wall that will, it'll work with the brick, it'll work with the OG mass timber.
Or even rubble stone foundations.
Yeah, yeah, for sure. Yeah, the rubble foundations as well. Yeah. So we've got two types of Visconn. We got the Visconn and the Visconn fiber. And the fiber is for the really big gaps. So if you've got big gaps in your rubble wall, just go with the Visconn, just take a brush, brush those up. And then once you're done with that, just spray the whole wall on the inside with the Visconn. And then you've turned a rubble wall into an airtight layer, which would have been impossible without
Well, it's
fluid
really
applied air
like
barrier.
to me, it's really the replacement of the spray foam. I think that composition, Viscon plus a vapor open insulation and an Intello, you're kind of covering the whole deal, and you're getting the benefits that, I mean, cu- for me, really the Viscon and a liquid applied membrane is getting in those little corners that you would never be able. I mean, if you had all the patience in the world to get a membrane and to get a tape and to tape all around, it's doable. It just takes more time, and it takes patience. So I think that helps. Or a rubble foundation, it's an uneven surface.
Yeah.
So I think that's why a lot of people would say, like, well, that's why I'll do a spray foam on it. But
Yeah.
then again, you're maybe harming your wall a bit more.
Well, yeah, Viscon is a great product again, yeah, because of the versatility. The fluid applieds are great because of that. It really, really helps to reduce the labor costs in getting a good high performance build as well. I mean, I think about joist spaces all the time. The joist space between floors or something like that. Like you could wrap Intello in each of those joist spaces and tape every single joist all the way around, or you could just use Rockwool and Viscon and be done with it. And it's a much better solution than just using spray foam there, which a lot of people will still do. Um, but yeah, that's where I come in. That's where some of the other products come in as well that are becoming more popular. It's like we're trying to make high performance the norm. And in order for it to be the norm, we need to be able to speed it up. And that's where I mean, if we want to talk about prefab, we can talk about prefab and all that stuff too. But yeah, I find that especially in retrofits and in site built projects, people are using Viscon for at least one of the details to speed things up.
Well, definitely new construction, it's easier to get that sequencing, especially in prefab. Like you said, I think prefab, personally, I think new construction should now majorly be prefab. It's just a more efficient way of building. But there's still we're still not done with the old way of building, and we need to be, especially for retrofits, be creative. So those products allow us to be creative and find different ways of doing things. Maybe you can guide us also through some tips and tricks for air sealing. I know that there's the famous floppy bit concept, and many others. Can you give us your best tips for air sealing?
Yeah, sure. Sure. Yeah. So this is pretty much the bread and butter of what I do with regards to support for builders and oftentimes designers as well. It's trying to figure out what's the quickest, easiest, cheapest detail to do in those tricky spots that is also well performing. So, yeah, I mean, there are certain parts of the air barrier that are way easier to air seal than the others. Way, way, way easier to just slap a membrane on a wall than it is to try and find that transition piece between a floor and a roof, or from a wall to a roof or something like that. Because oftentimes as well, you're kind of integrating the existing framing into the air barrier as well, and you gotta kinda trace like, "Oh, okay, well, I gotta tie it up to the top plate here, and then the top plate's part of the air barrier here, and then I'm going up." Um, so, yeah, like, when it comes to a couple of those details that I really, really like, oftentimes they're gonna be highlighted on our Instagram account. So feel free to give that a follow because we're constantly putting out video content about that, making high performance simpler and more accessible. Because I find that construction and um and I guess bringing knowledge into construction is best done through videos and photos and just visual content. So that's really what we're trying to push. So for instance, one of the details that I really, really like is transitioning the interior air barrier from between floors. And we've got a really great video of Connor Malloy's place, who's a great professor at George Brown. He's a part of BS and Beer
Love
Canada,
Connor.
and he's a friend. Yeah, he's a good guy. Um, he has a really great detail outline that I took a video of, where what he did was he had his interior air barrier running up to the bottom of the joist, and then he connected that membrane to a piece of plywood blocking that he cut out, and then he tacked that plywood blocking to the joist and used the Viscon around the edges to air seal it all the way around. So then you've got continuity from your interior barrier to that piece of plywood blocking once you tape to the bottom, and then you've got continuity kind of through the subfloor because you taped or you sealed to the subfloor that piece of plywood blocking. And then on the second floor, as long as you seal or tape that membrane to the subfloor, you're continuous going all the way up. So that's a great detail for a number of different reasons. Probably the one that I like the most is that you're dealing with something solid. It's really, really hard to cut a membrane around a joist space and try and like flop it into the joist space against rock wool and then try to tape it. If you've got something solid there and it's tacked, super, super easy to tape to or air seal to or connect to.
That's where creativity comes along, right? An air barrier is not necessarily a membrane. It's literally something you can't blow through it.
Yeah,
At its
exactly.
simplest, let's say,
Yeah,
right?
for sure. And that's what I love about this job too. It's like I'm part of a very small aspect of building and construction, but there's so much creativity with it, and there's so many different ways of doing things that I've learned from, great builders. And I'm just trying to bring out as much of that information as I can to other people, and that's what we're trying to do through Instagram and LinkedIn and stuff like that. Um, just to show that, this is a part of the craft as well. Part of the part of the aspect of building a good house is building a good enclosure. And that's one of the things that I really learned when I was working for that builder in Collingwood, and I fell into the building science rabbit hole because, I was working on big houses with hidden wine cellars and beautiful finishes and beautiful tile and bathrooms and kitchens and stuff like that. And there was so much craft and respect in that aspect of the construction. But now we're starting to see that level of detail and that level of respect and just interest and passion into the building enclosure as well, which I absolutely love.
I think the goal is also to try to make it, uh, well, to optimize also the cost of it, right? We're always pushing for higher insulation, um, some materials that are, yes, are a bit more costly, but it's also about finding the ways of saving money some other place, right?
Mhm.
If I take an example, for example, of like a service cavity here in Quebec, we're very big on poly, and at every electrical box on a poly wall, there's sort of like this plastic little container that they try to tape the box into. It takes at least per box 15 minutes for an electrician to really get the detail right. Whereas if you just add like a service cavity, um, you're saving those costs, right?
For
So I
sure.
think is by being creative, we'll find, like you said, we're trying to always find the cheapest and most effective way of doing these things.
Yeah.
And through the knowledge that you guys share, it's really what you showcase.
Yeah. We're trying to systemize it slowly but surely. Yeah. We've been around since 2011. Um, I mean, we started off in Brooklyn and kind of expanded from there. But yeah, I mean, we've been working on those ebooks, those 60 or 70-page ebooks that have all the CAD drawings. We've been working on a whole bunch of blog posts and videos and photos because, I mean, I'm speaking for the rest of 475, but I think we can all agree on the fact that, the materials, they'll only perform as well as they're installed. So we have to be as concerned with how things are installed as Proclima in Germany is concerned with the quality control of their product. So that's why we're trying to make it as easy for everybody, because we want the system to work well, not just to the benefit of the builder and the benefit of the home builder, but also to make our lives easier too.
Absolutely, we'll definitely be putting the knowledge resources guides in our description. I use them all the time. It's so much great information. They give you different types of, different building types, whether it be new construction, retrofit. And again, it just helps to use your products as a system.
Yep.
Always keeping the building science as number one.
Yeah, we don't have a ebook for PS sur PS yet, or Quebec block, but the one that would be most, I'm sorry, I'm butchering the French. I'm so sorry.
No, it was actually great. Pièce sur pièce, you had it good.
I know. I took French till grade 11 too, which is crazy. But
It's showing up.
the one ebook that would be most valuable for that type of construction would be the masonry retrofit one. So
Absolutely,
whenever
yeah.
I hear, or whenever I get an email or a phone call saying, "Oh, I'm doing a retrofit of a townhouse in Montreal," it's like, "Oh, masonry retrofit ebook. That's the one to go to." Even though it's for like double width or triple width brick, like a structural brick wall, all of those same concepts that you see in that ebook would apply to the OG mass timber that you see in Montreal. So that would be the good one to go to.
Aaron, thank you so much for your time. I really appreciate it. You can find all the product descriptions or everything that we talked about mentioned in this episode. You'll find it in the description. But thank you for your time. Really appreciate you coming here.
Yeah, no, it was fun.
Yeah, thank you, Aaron.
Thanks for having me. Yeah, have a good one.
Yes, you too.
Thank you for joining us for another episode of the Beyond the Walls podcast. And a special thanks to our guests for sharing this great moment with us. Visit our website at addm.ca for more information about today's guest. You can listen to all of our episodes on Spotify, iTunes, or YouTube. And don't forget to subscribe so you never miss an episode. We'd love to hear from you. Comment on the podcast, share your ideas, and connect with us on LinkedIn, Facebook, or Instagram, or drop us an email at info@addm.ca. For all your high-performance, net-zero retrofit needs, reach out to Fellipe and his team at Retrofit Construction. That's RETROFIT construction.ca. For the most efficient construction materials in stock for your sustainable building projects, contact JS and his team at gopassif.com and have them delivered directly to your construction site. Thank you once again, and see you on the next time.